So remember from example number, it was example number 3. Oh, example number 3, yes. On example number 3, we're trying to determine where is our arm going to lie. Now, how do you know where your arm is going to lie? First, you need to make sure with the trig ratio is the subject. What is the trig ratio? Tan is a trig ratio. Okay? So you are going to make tan the subject here. If you make 10 the subject here, you are going to have 4 the tan of beta or tan of b is going to be 3. You divide by 4, you divide by 4. It says, therefore, the tan of b is going to be equal to 3 all over what? All over 4. So what are they saying here? We want tan to be positive. That's what they're saying. Because the fraction here is what? It's positive. So where do we expect 10 to be positive? All students take proof. Where is tan positive?
The first and the third.
First and the what and the 10. Now, not only do we want 10 to be positive, this part is saying we want where the 10 is going to be positive, but we want cos to be negative, less than 0 again. Where is cos going to be negative? We know which cos is positive here. Agree cos is positive here. And then it's also positive here again. It means which everywhere else now cos is going to be what to be negative. So where is cos going to be negative? It's going to be negative on the second again. And the third quadrant. Now, who has 2 cheeks, man? The third quadrant. Now, this is where we are going to draw our terminal arm. And then we tell them, starting from here up until we get here, this is going to be what to be theta. Oh, it's B. Yeah, you're correct. It's B. It's not theta. It's just that I'm used to theta again. So this one, it's B. This angle here is going to be B. Okay, now as soon as we are done here, we are then going to say the trig ratio is going to give you certain sides, and then there's going to be one which is missing. Okay, now trig ratio is going to give you its so car and then we said this is Y, this is R. This is X, this is R, this is Y and X. Okay. Now, what are we looking for? We are looking for 10. We're looking for 10 because here we are given 10. So what is 10? Opposite given. It's opposite all of adjacent. Now, based on what we said which opposite is Y, and then adjacent is what? It's X. Opposite all over adjacent, that's tower, soccer toe. So you have X, which is 4, and then we have Y, which is what? Which is 3. But why in the third quadrant here? You should come and scrutinize this thing that you just said, man. You come here and say, hey, on the third quadrant, let's check X. What do you think about the X values here? These X values here. Are they positive or negative? Yeah. These X values are negative. So it means with this thing here, I can't say X is negative 4. I'm going to say X is going to be minus 4. And then you come and check Y here. What do you say about Y here on the third quadrant here? It's also what? Negative. Then it means what you're going to tell them with Y is minus what? Minus 3. And then the question might be, Marasa, how did you end up having a term which is positive? Actually, we had a negative and a negative. What is a negative and a negative? Yeah, a negative and a negative. That is why we ended up with what? With positive 3 all over what? All over 4. But this one, 3 is negative and 4 is also what? Negative. But if you find a negative and a negative, they then give you what? A positive. Then you can come and update your diagram and say, okay, but this one here, it's minus 3. But this one here is what? It's minus 4. Who's missing now? The radius. Again. Now we're going to find the radius. R squared is going to be equal to minus 3 all squared. No? Plus, this is how you type it in your calculator. You say open bracket minus 3 all squared. And then you have minus 4 all squared. And then it says which R is going to be 25. No? And then you say R squared is going to be square root and a square root. It says R is going to be plus and a minus 5. Now we're talking about R. Am I going to take the positive or the negative here? R is always positive, okay? The radius is always going to be positive. Then we update our diagram, man. Now that our diagram is complete, then we're going to do exactly what we did from example number 1. We're going to use this right angle triangle. If this is confusing for you, friend, you can do this. You can take out the right angle triangle like this and say, okay, yeah, I have 9, okay? And then here, I have this one here, it's equivalent to you having B. So you can just write the B there. And then you say here you have -4, and then here you have -3, and then here you have what? 5. Now, define sine. How do you define sine? It's opposite all over hypotenuse. Now, what is opposite to B? It's 3. Yeah, you can do that. Or you can come and tell them, with this thing, basically, it's like having Y. It means that basically we have Y all over R. That's sine. So instead of writing sine beta, I can write what? I can write Y all over what? All over R. Instead of writing cos here, I can write it as X all over R. But now, let me put a space here. So what do I have for number 1? I am going to tell them what I have open bracket. I have Y. What is Y according to this diagram here? -3. What is R? Plus -4 all over 5, okay? All squared. And then if you were to do this, it says the numerators, you are adding fractions. If the denominators are the same, you simply the numerators. Then what are you going to have here? You're going to have -7 all over 5 all squared. This is going to give us 49 all over 25. And then you can see, instead of sine, you see, instead of sine, I put what? I put Y all over R. Instead of this sign here, this whole thing here, I'm changing it, and then it's going to become what? Y all over what? All over R. But I know what is Y. I also know what is what? What is R? Then when you can come and do the following here now. I think you can do activity number 5 now. You should be able to do activity number 5.
Okay.
Yeah. Not now. Agree also to